This video is a continuation of where we stopped in the last video on joint cases on small and great circles. So, an aeroplane flies due north from a town T on equator at a speed of 950 kilometers per hour for 4 hours to another town P. It then flies eastward to a town Q on longitude 65 degrees east. If the longitude of T is 15 degrees east, A represents this information in a diagram. So, an aeroplane flies due north from a town T. We show that T is on longitude 15 degrees east and equator. Equator is latitude 0 degrees, 15 degrees. This is longitude 15 degrees east. So this is point C. Alright. C on equator at a speed of 950 kilometers per hour for 4 hours to another town P. So another town P due north to P. So let's say this is a P is. Alright. It then flies eastward to town Q on longitude 65 degrees eastward. So longitude 65 degrees. It's 5 degrees east. So eastward. So in that town Q. This is town Q. That's town Q. 65 degrees east. So represents information in a diagram. So for the first one, so represent this information in the diagram. This B is the diagram that would. Okay, so this is the diagram. Now the B says calculate the latitude of P correct to the nearest degree. Alright, since the P and T is on the line of longitude, and since P and T is on the line of longitude, that is the distance between P and T is on a great circle. So we have here, this is P and D. This is the radius of the great circle, which is this line from equator. So let's say the center is O, center of the great circle is O. So longitude P is 15 degrees. Longitude P is 15 degrees east, and that of longitude T is also 15 degrees. So latitude P is what we are going to look for. Find latitude of P. I'm going to say, so B, this is A, so B, BI, let the latitude of P be theta, and that will give us, so from the equator, remember that the latitude of equator is a parallel line of latitude. In fact, it's a reference line of latitude from whichever the line of latitude is measured. Every other line of latitude is parallel to the equator. That's why it's called parallel lines of latitude. So since C is at the equator or is on equator, that means T is 0 degrees, and then P. So that will give us the angular difference is equal to 0 degrees x plus 0 degrees. So why? Because T is on the southern hemisphere and P is on the northern hemisphere. So you're going to add the latitude, angular difference. So okay, let the latitude of P be x degrees now. So the angular difference is simply difference in latitude in this case. Angular difference theta is equal to x degrees, which is the latitude of P, plus the latitude of T, which is 0 degrees. Why? Because T is on equator, and the latitude of the equator is 0 degrees. So P is x degrees, 0 degrees. So altogether you have x plus 0 degrees will give x, so x degrees, and this is what we are looking for. So we're going to say let's so now latitude of P corresponds to the nearest degree, but P and T is on great circle, so distance. To get the latitude of T, we're going to have distance P PT equal to along the line of longitude, 15 degrees is that is a great circle is equal to theta over 360 degrees times 2 pi r. And this would give me, so theta, the distance is given to us as it says an aeroplane flies due north from a town T on equator at a speed of 950 kilometers per hour for 4 hours to another town P. So we're going to get the distance PT from speed. Since we don't know the distance and we're given the speed, so first of all, speed is equal to distance over time. And we're given the speed and we're given time, so distance is equal to speed times time. So this will give us 950 kilometers per hour times 4. So 950 times 4, 3,800 kilometers. So that's the distance between P and T. PT. Now that we've gotten the distance, we can also distance PT is equal to, and the angular difference is x, is equal to theta over 360 degrees times 2 pi. So distance PT is 3,800 is equal to x degrees over 360 degrees times 2 times pi is 22 over 7. 2 over 7 times r is 6,400. 6,400, so 3,800 is equal to 2 times 22 times 6,400, 281,600 x degrees over 360 degrees times 7 will give us 2520. So cross multiplying, we're going to have 3,800 times 2520 is equal to 281,600 x degrees. So x degrees is equal to 3,800 times 2520, 9576, 000 divided by 281,600. So x degrees is equal to divided by 281,600, 34 degrees. So x is 34 degrees. So that is to say, therefore, the latitude of P is 34 degrees north. Number figure 2. Number figure 2 says we should find the distance between P and Q correct with 4 significant figures. So what we can see here, P and Q lie on the same line of latitude. So on this same line of latitude, P and Q, and P and so this line of latitude has been identified as latitude 34 degrees north. So it's a latitude 34 degrees north. So Since the line of latitude is a small circle, so it's going to connect these 2 points. All right, so here we're going to have something like this, and this is Q, this is P. Okay, so longitude P is 15 degrees east, 10 degrees, and longitude Q is 65 degrees. 65 degrees. So altogether, so we're going to say angular difference, which is difference in latitude, since they are on the same line of longitude. No, since they are on the same line of latitude, difference in longitude is equal to both P and Q are on the same side of the globe. So you're going to subtract 65 degrees minus 15 degrees. That will give us 65 minus 15, 50 degrees. Angular difference is 50 degrees. Next is, so distance. So because both P and Q are on the same line of latitude, the distance PQ is on the parallel line of latitude. So distance PQ along the parallel of latitude, along the parallel of latitude 34 degrees north is equal to theta over 360 degrees times 2 pi r plus alpha. Distance PQ is equal to, so theta, angular difference is 50 degrees over 360 degrees times 2 times 22 over 7 times 6,400 times cos 34 degrees. 50 times 6,400 times cos 34, 11672849.02 divided by 2520, 4632.08 kilometers approximately. So 4 significant figures, 1, 2, 3, 4. So that will give us 4632 kilometers to 4 significant figures. So that's the answer. Number 2, P 55 degrees north, 16 degrees west, Q 55 degrees north, X degrees east, and S Y degrees south, 16 degrees west are 3 towns on the Earth's surface. 3 towns on the Earth's surface. The distance between P and Q along the parallel of latitude 55 degrees north is 3,800 kilometers, and the distance between P and S along the meridian 16 degrees west is 5,000 kilometers. Calculate correct to the nearest degree the value x degrees to angles subtended by arc PS at the center of the Earth. So P 55 degrees north, latitude 55 degrees north, 16 degrees west, longitude 16 degrees west to this point P. The next one is Q 55 degrees north and X degrees east. So this is Q, X degrees east, X degrees east, and point S, Y degrees south, latitude Y degrees south, 16 degrees west. So this is point S. Okay, so the question says we should look for the value x degrees. So x degrees is between P and Q, point P and Q, and that's a small circle because both P and Q are aligned on the same line of parallel line of latitude. So this small circle, so this is the radius of the small circle. Let's connect the 2 points together. So we have PQ connected. So we have this, and this is the radius of the small circle. All right. PQ, they are both lying on the same line of latitude. So the angular difference will be the difference in longitude. So PQ longitude P is 16 degrees. 16 degrees. Longitude Q is 55. Longitude Q is x degrees east. So we are looking for x degrees. All right. So now take note that since our angular difference is angular difference is equal to theta is equal to angular difference will be difference in longitude. Now the difference in longitude, both P and Q are on different sides of the globe. P is on the west, Q is on the east. So we're going to add the angular differences. So 16 degrees plus x degrees. So theta is equal to 16 degrees plus x degrees. So let's look for theta first of all. So and x will give us okay, the distance PQ along the parallel line of latitude 55 degrees north is theta latitude 60 degrees times 2 pi r by r cos alpha. So but we're given the distance PQ. So the distance between P and Q along the parallel of latitude 55 degrees north is 3,800 kilometers. So 3,800 is equal to theta latitude 60 degrees times 2 times pi is 22 over 7 times 22 over 7 times 6,400, which is the radius of the earth, times cos 55 degrees. So 3,800 is equal to 2 times 22 times 6,400 times cos 55, 161 519.1245 divided by 2520 theta times theta. So here's over 1. So cross multiplying 161 519 519.1245 theta is equal to 3,800 times 2520 957 600. So theta is equal to 957,600 over 161,519.1245. So theta is equal to divided by 161,519.1245, 59.29. Theta is 59.29 degrees, but theta is equal to 16 degrees plus x. 16 degrees plus x degrees. So x is equal to theta minus 16 degrees. So x is equal to, x is the latitude, x is the longitude of Q. So x is equal to 59.29 59.29 degrees minus 16 degrees, and x is equal to 59.29 minus 16, x is equal to 43.29 degrees. X approximately is equal to 43 degrees east to the nearest degree. So that's the value of x. So over figure 2. Figure 2 says angle subtended by arc PS at the center of the earth. Arc PS is, since both P and S are on the same line of longitude, that's a great circle. So arc PS is like this. The radius of PS. So latitude P is 55 degrees north. 55 degrees north. Latitude S is equal to y degrees south. Y degrees south. So since both of them are on different side of the globe, then so let's the latitude. In fact, let the latitude of S be y degrees, and then you say angular difference. There is difference in latitude. Angular difference theta is equal to 55 degrees plus y degrees. However, this is what we really need is theta. That's the angle subtended by arc. That's all we need, which is this total angle, and that's the angular difference. Just that once we get angular difference, we can know y. But y is not y. Y is not why we are solving for theta. Actually, theta is what we are looking for, which is the angular difference between this and this. That means angular difference between P and S, which is the whole of this from this line to this line, and that's the value of theta. Just that once we get value of theta, we can get the value of y. So angular difference is equal to 55 degrees plus y. Now let's go on. Now the distance, PS is a great circle. So this is distance PS along the line of longitude, 16 degrees west. 16 degrees west is equal to theta over 360 degrees times 2 pi r. And now the distance PS is given to us as 5,000 kilometers. This will give us 5,000 equal to theta 360 degrees times 2 times 22 over 7 times 6,400. So 5,000 is equal to 2 times 22 times 6,400. 281,600 theta over 2520. So cross multiplying, 281,600 theta is equal to 5,000 and 2520. 281,600 theta equal to 5,000 times 2520. 126, 123. So theta is equal to 126 divided by 281,600. So theta is equal to divided by 281,600. 44.74 degrees. So approximately theta is equal to 45 degrees south. to the nearest degree. So the angle subtended at the center, the angle subtended by arc PS at the center is equal to 45 degrees south. So this is what we're told to look for. And arc PS is the angle subtended by P, that is from here to here to the radius, which is line P, and here to here. So once we have done the angle subtended by arc PS at the center, we can also get the latitude of S. So say from here, we can say but theta is equal to 55 degrees plus y. So y degrees is equal to 55 degrees minus 44, 44.74 degrees. (10.26 degrees). A point Q lies on latitude 48 degrees north. Find the speed of Q due to the rotation of the Earth. Take the radius of the Earth as 6,400 kilometers and pi 22/7. Parallel of latitude. Latitude 48 degrees. Latitude 48 degrees north is the North Pole. This indicates the rotation of the Earth, and so Q, this point Q, traveling the circumference of parallel of latitude 48 degrees north equal to 2 pi r. 2 pi r, but r is equal to r cos alpha. So the circumference is 2 pi r cos alpha. 2 pi r cos alpha. And this will give us 2 times 22/7, 6,400 cos times cos 48 degrees. Rest 7, so that will give us 188,427.1788 divided by 7. 26918 26918.16829. Okay, so this is the circumference of the parallel of latitude 48 degrees north, and the question says that we should find the speed of q due to the rotation of the earth. So speed is equal to distance over time, and that will give us, so the speed is equal to, the distance is the circumference, that's the distance around this small circle. So the speed is equal to distance over time. But here the distance is circumference. Speed is equal to circumference over the time. Circumference of circle over time. So the speed is equal to 26918.16839 over 24. In 24, that's due to the rotation of the earth, it takes 24 hours for one complete rotation. So the time is 24 hours for a complete rotation for the for Q to travel around the small circle to complete one rotation. So speed is equal to, therefore this will give us 269 divided by 24. So 11.59 kilometers, and this will give us to the nearest two significant figures, give us 1100 kilometers. So two significant figures. An aeroplane flies from a town P, latitude 40 degrees north, longitude 38 degrees east, to another town Q, latitude 40 degrees north, longitude 22 degrees west. It later flies to a third town T, latitude 28 degrees north, longitude 22 degrees west. Calculate. So let's just forget our diagram. So flies from a town T, 40 degrees north, latitude 40 degrees north, and longitude 38 degrees east. 38, longitude 38 degrees east from town P to another town Q, 4th latitude 40 degrees north, longitude 22 degrees west. Longitude 22 degrees west. Town Q. It later flies to a third town C, latitude 28 degrees north, 28 degrees north. Oh. So this will give us latitude 28 degrees north, latitude 28, 28. Okay. Since this one is latitude 40 degrees north, this one should be down. This latitude is higher than town C. So it's going like this. Latitude 28 degrees north. So because latitudes, they increase as you go up the equator. They decrease as you go, so as you go up the pole, the northern pole. So the equator is 0, so from 0 upwards, the lines of latitude increases. So if this latitude 40 degrees north, then this one should be latitude 28 degrees north, should be down. So the next one, 28 degrees north, and longitude 22 degrees west. So they are the same line of longitude. So points, that's point C. So this is T, point T. Okay. These are the 2 points. Now the A says calculate the distance between P and Q along their parallel of latitude. So parallel of latitude means it's a small circle. So we're going to do that now. So A, distance P, Q along the parallel of latitude is latitude 40 degrees north is equal to theta 60 degrees times 2 pi r cos alpha. The angular difference, which is difference in longitude, angular difference theta is equal to, so we have Q, longitude Q is 22 degrees, longitude P is 38 degrees. So we're going to add because they're on a different side of the globe. 22 degrees plus 38 degrees. 60 degrees. So distance PQ is equal to pi is 3.142. So 60 here, 1, 60 here, 6, and 2 here, 1, 2 here, 3. So 3.142 times 6,400 times cos 40 15,404.2305 divided by 3. 5134.74 kilometers. Okay, so two significant figures, approximately 5100 kilometers to 2 significant figures. So that's the answer to A. So B says distance between Q and T along the line of longitude. Q and T, since it's a great circle route, they are on the same line of longitude. So B, angular difference theta is equal to QC. Latitude Q is 40 degrees north, 40 degrees minus latitude T is 28 degrees. We're subtracting because both Q and T are on the same side of the globe. So theta is equal to 40 degrees minus 28, that's 12 degrees. So distance QT along line of longitude is equal to theta, which is 60 degrees times 2 pi r. So theta is 12 divided by 2 is 60 degrees times 2 times 3.142 and 6,400. So 12 here, 1, 12 here, 30, 2 here, 1, 2 here, 15. So 3.142 times 6,400 2 201 08 201 08 times 8 divided by 15. 1340.59 kilometers, approximately 1,300 kilometers. So two significant figures. So C says average speed at which the aeroplane will fly from P to T via Q. So average speed at which the plane will fly from P to T via Q. So which means if the plane must fly from point P to T, it has to fly from P to Q first, P to Q then plus from Q to T. So average speed, remember that average speed is equal to total distance covered, total distance covered over total time taken. So speed, average speed is equal to total distance covered is distance from P to Q, that's PQ, then plus QT over time. So the average speed is PQ, distance PQ is equal to 5134.74, 5134.74 plus distance QC is equal to 1340.59 over the total time taken by the journey is 12 hours divided by 12. So 5134.74 plus 1340.59 6475.33 divided by 12. So divided by 12, 539.61 kilometers. So approximately the average speed is two significant figures, 540 kilometers to 2 kilometers per hour to 2 significant figures. Two places, X and Y, on the same latitude, 52 degrees 30 minutes north, have longitude 61 degrees 81 minutes east and 58 degrees 42 minutes west, respectively. So let's plot these points in the graph on the in the diagram. Okay. So north, south, west, east. So longitude 52 degrees. This is latitude. Take note that 1 minute is equal to 60. 1 degrees rather. 1 degree is equal to 60 minutes. So we're going to do that conversion. So we're going to convert 30 minutes to degrees. So 30 minutes over 60 is equal to 0.30 divided by 60, 0.5 degrees. So when you have 0.5 degrees plus 52 degrees, it gives us 52.5 degrees. So this will give us latitude 52.5 degrees north. Then we also have to do same for the rest. Longitude 61 degrees, 81 minutes east. 61. This longitude. 81 degrees divided by 60. 81 divided by 60. That's 1.35. So 1.35 plus 61 plus 61 will give us 62.35 degrees. 62.3, so 62.4. I'm going to approximate it. 62.4 degrees east. So this point X. So Y is 58, 52 minutes west. So I'm going to convert 42 divided by 60 is equal to 0.7. So 0.7 plus 58 at 58.7 degrees west. So this is longitude 58.7, longitude 58.7 degrees west, and this is point Y. So A says the distance between X and Y along the circle of latitude 52 degrees 31 minutes north, and this is equivalent to 52.5 degrees north. So A so Y and X. So longitude Y is 58.7 degrees. Longitude X is 62.4 degrees. 62.4 degrees. So angular difference theta is equal to 58.7 degrees plus 62.4 degrees. One two 1.1 degrees. Okay, so distance X, Y along parallel of latitude and parallel of latitude 52.5 degrees north is equal to theta 060 degrees times 2 pi r cos alpha, and this is equal to theta is 121.1 degrees over 60 degrees times 2. Pi is 3.142. R is 6,600 kilometers. Always make use of what is given to you here. 6,600 kilometers times cos 52.5. This will give us 121.1 times 2 times 3.142 times 6600 times cos 52.5 30.7534.618 over 360 degrees. So divided by 360, 8493.15 kilometers. So I'm going to correct the answer to two significant figures at 8,500 kilometers approximately. So two significant figures. So that's A. So B says the latitude between two places P and Q on longitude 61 degrees 18 minutes east and 58 degrees 42 minutes west. If the distance between P and Q is 3 over 2 times the distance between X and Y, take the radius of X to be 6,600 kilometers and pi 3.142. So the latitude between two places, that means both that is to say that P and Q is a distance on, so the latitude between two places P and Q, let's locate it, 61 18 degrees is 61. That's this longitude, and Q is 58 degrees point 42 minutes. So this longitude P and Q. So let's put this one is on the west, and this is so the latitude means a line of latitude going across these 2 points. So is it, let the latitude be latitude y degrees. So let the latitude be let the latitude be y. Well, okay, the latitude between places P and Q on longitude 61 degrees east, and so I wouldn't say the latitude is on the south or the north. We don't know, so it's not really good for me to write and draw the diagram here, because the question did not indicate whether the latitude is on the northern hemisphere or southern hemisphere. However, since we are looking for the latitude, that means the latitude is going to be common to both the point P and point X, and that is to say that it's going to be a parallel of latitude also. So I'm only going to say let the latitude be alpha, rather, so it's going to be common to both points. So our angular difference will now be difference longitude, angular difference between P and Q, angular difference between PQ, between P and Q is equal to, that is theta, okay, that is theta is equal to difference in longitude, that is 62 degrees, 62.4 degrees east minus plus 58.7 degrees west. That will give us 62 points. Okay, it's exactly what we did here. So that's okay, 16.4 degrees plus 58.7 degrees. That's got 121.1 degrees. So distance PQ along the parallel of latitude alpha degrees is the theta 60 degrees times 2 pi r cos alpha. But so that distance PQ is equal to 3 over 2 times distance xy times 3 over 2 xy So distance PQ is equal to PQ is equal to 3 over 2 times xy. The distance of xy is 849.15. That will give us 3 times 8493.15 divided by 2. 729.725 kilometers. So I'm going to use, so this is the value distance PQ. So I'm going to say PQ, so PQ is equal to theta, which is 60 degrees times 2 pi r cos alpha. So PQ is equal to 12729.725 is equal to theta 121.1 over 360 degrees times 2 times 3.142 times 6 600 times cos alpha into 729.725 is equal to 121.1 times 2 times 3.142 times 6,600 times 6,600 is equal to 502,549.84 cos alpha divided by 360. So cross multiplying, you're going to have 5022549.84 cos alpha is equal to 360 degrees times 12739.725. So cos alpha is equal to 360 times 12739.725. 360 times 12739.725 by 46454586301 divided by 5022549.84. So cos alpha is equal to 5022549.84. 5022549.84 0.9131. So alpha is arc cos 0.9131. So alpha is equal to sheet cos 0.9131 24.06 degrees. So therefore, now since in the question we had both angle and minutes given, so we're going to ensure that the line of latitude between P and Q is also in degrees and in minutes. So this part, so this will be alpha is equal to 24 degrees 0.06 times 60 minutes. So this will be 24 degrees 0.06 times 60, 3.6. That's approximately 4 minutes. So when I say therefore, latitude is 24 degrees 4 minutes knots.